Hey, how are we doing, everybody? Let's see. I think we got everything going. I feel like the audio is playing. I guess it's not. There we go. There we go. How's everyone doing? So we have Kiana here and Tiffany. Kiana says, and well, you got it, Tiffany. Thank you so much. I'm throwing some 50 points for positivity. Mubot, you awake? We'll see if Mubot's awake. Maybe. For some reason, YouTube always defaults to top chat. I want to go to live chat. It looks like Mubot's not awake. Let's go wake up Mubot here. Wake up Mubot. And Mubot is waking up. Kiana says, hey, Brian, I was wondering if we could go look at 3B on the lab for 474. I can't seem to figure it out. Yeah, let's go take a look at that. I think it's lab 1. I have that open, I think. Lab 1. I was eating a snack real quick. 3B. Let's go take a look at some 3B on lab 1. Here we go. 3B, lab 1. Can everyone hear and see me? We'll pause for a second here. Am I streaming live? Can everyone hear and see me? I'm going to disappear. You'll no longer be able to hear and see me here in a second. Oh, you can't see me now. No one's responded in the chat, so I'm a little worried. Awesome. I'm not going to eat on stream. Ah! Okay, I'm back. Okay, let's do this. Let's hop over to the main screen. Let's do some 3B for 474. Thank you so much, Leah. Kiana, good to see you. I promised 50 points. Mubot is awake now. Mubot, you need to give out those points. Mubot's giving out points. Let's do this 3B for 474. Here we go. Okay. So we got right here a bunch of plots and stuff. 3B. Okay, this is the activity 3B for 474. We've got here real world data can often be messy. There's typos. There's so many issues with data that just occur. We need to make a vector. So a vector is just a what? When you think about a vector right here, what is a vector? Because anyone in the chat, while I'm talking about this and explain this, kind of put in their own words, what is a vector? It says we need these elements in it. So here I'm just going to copy this. And this won't make a nice and neat vector yet. These are nice, but this is not nice. So let's make it nice by typing SQRT and going here. Did I hit insert? I don't know what I even hit. There we go. That's the square root of 39, log 10 of this. Let's go log 10 of this right here. And now we've done it. That's a vector. And let's store it by left arrowing. Kiana likes those points right there. Storing it into BAS. So please look at the steps right here. Understand that we have, what is the length of this vector? Let me ask that for 20 points. 201, you can figure this out also. What is the length of this vector right here? It's got in it how many elements, how many observations are in this? What is the length of the BAS vector? What is the length of the BAS vector? There's hints on the screen now. What is the length? Great job right there, Kiana. Yeah, it might look a little longer. It is 6. There are 6 elements in the BAS vector. And you can see them over here. So you can actually see the numbers right there. No worries, Kiana. 20 points in the chat. Great job, Kiana. Just following along, practicing, and doing this right here. So we've got bogus values. Wait, was that supposed to be negative? Oh, wait. Oh, really? I forgot some stuff. The square root of 39, the log 10 of this, the number e raised to this, and this. Well, it's supposed to be 8, Kiana. Kiana, I'm throwing some 50 points. Kiana, you were right. It is length 8. Brian just forgot to add in some stuff. So the actual answer is 8. Brian didn't add in these extra things. To do e raised to the power, Kiana's like, mine actually has 8, Brian. Yours has not 8. Yours is wrong, Brian. That is correct. The only one we have a mistake on right now is the power of e, or e raised to a certain number. Kiana, how do we use e, but like instead of writing e, we can do e raised to a number, which is a function inside of R. Very important thing to know how to do e raised to a certain power. It's a function inside of R. Like if you want E, you could do this right here. You could type a little small 3-letter function. EXP, you got it. Great job, Kiana, right there. That is E right there. That is E raised to the power of 1.5. So we're just going to copy paste this. And whatever you put inside of this function gives you E raised to that power. So if you just want E, you're just doing right here E raised to 1. Now this E does not exist inside of R, so it's going to get mad at me. If I really wanted E to exist, I could store E as EXP raised to 1, and now I can do E raised to 1. So I've created E. I don't suggest doing that, but let's say you're like, I really just like things to look like E. You could store the object E as E raised to the first power. That's what this code stands for here. Not really needed for this example, but it shows that this is E raised to the first power of 1. And if you were to change the value in the function, you'll be doing E raised to the 1.5 power. So we now have created our vector properly this time, and the vector has 8 elements in it. Wow. We've done it. Owen Wilson.
Wow.
He's very impressed. So with this right here, imagine these are bogus values. They're not real values. Now, when we think about this, we need to do this in steps. Step 1, find the bogus values. Positions. Oh, wait, no. Let's do this. Logically find the bogus values. Step 2, find the positions. Step 3, find the values in the bogus positions. Step 4, recode them. Okay. So how can we find the bogus values? Like, how can we logically find them? Let's say make a vector of bogus values. Step 0. So what is the vector of bogus values to begin with? What is the vector of bogus values? Like, I just want a vector of bogus values. Try putting that in the chat. Try putting a vector of bogus values. Create a vector of bogus values right here. Breaking things into parts helps. Yeah, Roger Kane time. That's the next question. We've got one more from, I think it was, is it Tiana asked it? Or Tiffany asked it. Tiffany asked it. I just combined Tiffany and Kiana right there to Tiana. What have I done? Great job right there, Kiana. We've got here bogus values. And so you can do it this way. I'm doing it a slightly different way today. I like doing problems so many different ways. I've heard internet is just insane today, and I'm sorry, OIT. I'm sorry, everyone. I don't want to be mean to anybody, but personal opinions. Personal opinions with Brian. We need to get internet fixed as fast as possible. Wow. Hot take right there, Brian. Hot take. Logically find the bogus values. So now we want to look to see if any of the BAS elements are contained in the bogus values. So now we want to logically find the bogus values. So we want to see if any of the BAS elements are contained in the bogus values. So now we want to see if any of the BAS elements are contained in the bogus values. So you could type a little part. I'm so sorry. I'm hoping we get it fixed up 100% here. I've got my mint chocolate chip bar. How do we logically find those values? I'm disappearing. We do need to do that. Sorry, please. Mm-hmm. Very, very true right there. Sorry, everybody. Very, very true. Are the elements of BAS contained in the bogus values? You can do it the way you've done it. This is 100%. So many ways to do this. So are the elements of BAS contained in that? Like, let's try a small code right here. Is 5 contained in the vector? Who knows what this will return right here? Is 5 contained in that vector over there on the right? Just think true or false. Is 5 contained over there? Is 5 contained over there? True. Oh my gosh. That is true. Look down here at the bottom. How about is 99 contained over there? Is 5 contained over there? So is 99 contained over there? Is 5 contained over there? And just think that's what it's doing for the BAS when we run it on bogus values, because these are just vectors. So is 99 contained over here? Or is 5 contained over here? What would this return? So just think, read it as a sentence. Is 99 contained over there? Is 5 contained over there? Contained means exactly. Kiana, excellent work. Kiana, you're earning some crazy points today. Keep those answers coming. Keep practicing. I can say all the answers. I can tell you how the code works, but it's your practice that makes it stick. So now we need to find the positions of the bogus values. How could we take this and find where the trues are? So how could we simply take what we've created right here and find the truths? Like find where the truths are at. We can see the answer should be 3 and 8. The answer should be 3 and 8. We should get 3 and 8 as our answer. That's what we should get. But how can we turn this into something that finds the positions of the truths? How could we take this and find the positions of the true right here? What would we put this inside of to find the positions of the truths? So what is a code? You got it, Kiana, right there. Great job. A which will take a logical vector and take wherever the truths are and return the position of the truths. So whenever you put something inside of a which takes a logical, which this is just logicals. If I put true inside of here, it'll return 1 because that's where the true is at. If I put something like true, true, it'll return 1, 2 because that's where a true is in position 1, true is in position 2. If I put a false here, we'll still get 1. So it's just returning the positions of where the truths are at because this is just a logical vector. Remember, this right here evaluates to this, so it's just a logical vector. So find the values in the bogus positions. So now that we have positions, I need to go to the BAS vector. And what do you think I'm going to do to find those values in those positions? We're almost done. It's a little bit of steps right here. What do you think we're going to do to recode or to find those values in those positions? Because now we know it's in position 3 and in position 8. So now we need to go to the positions to go to those positions and recode them. Great job right there, brackets. You got it. We're going to go inside of here, and those are the values. And now that we have the values, we can go here and recode them with missingness. We can check our work, and we've done it. There's a lot of ways to do this. You actually don't need to use the which, just kind of pointing to some additional ways to do it. I guess I could leave this as is, because you can put a logical to get positions. Just sometimes it makes more sense to get the positions. But a lot of ways to do this. This is how to do it right here. But does that make sense, Kiana, what we did step by step to be like, okay, what are the bogus values? Where are they located in this vector? Okay, let's go ahead and grab those values in the bogus positions and let's recode them. So coding is a lot about logic, and then we won't always be there to tell the steps. But the more you practice steps and the more tools you have, it's like when you're building something, you're like, okay, I got to make this. And then there's no instructions. It's like being a woodworker, but making a chair on your own. And you don't have like a YouTube video that says, here's how to make a chair. You're like, well, I don't know. When you make a chair, you do this and this, and then you got to do this next, and you got to make this part. And then you start designing new chairs. So, yeah, great job right there, Kiana. Let's do, I think it was Tiffany's question next. You got it. And Roderick, ask a question next. You got it. You're next. Tiffany asked, can we walk through Canvas content quiz? You bet. Let's do some Canvas content quiz. Awesome stuff right here. I was on Reddit this morning and I saw, I just saw the craziness about UT Wi-Fi, and I was like, oh my gosh, because I heard about it yesterday, and so, it's tough. I'm sure. I know some people know IT. I'm sure they're dealing with a lot right now. But we should be investing a lot in our internet. So let's see right here. Internet is important. Need the internet. Awesome. Let's go over here. Let's start up some Canvas content. Canvas content quiz due next Monday. But we got this. So Tiffany, we're going to start some Canvas content quiz. Here we go on the Canvas content quiz, Chapter 1 and Chapter 2. So make sure you're using, do not use Safari. Don't use Safari. Use Chrome. Question 1 is the variable average of chocolate rating. What kind of variable is it? Ooh, we might get that. So if you went to a company, maybe we'll get that. Let's see if we got the average chocolate rating one. So let's redo it. We're going to try to get that average chocolate rating one in part of this to talk about it. Really? Oh, here we go. Average chocolate rating. What does that look like? We'll do two versions of this. Average chocolate rating. What does that look like? So we have here, we go to a company and we say, how much is your average chocolate rating? Great way to ask it right there. And just look at the variable and be like, are those actual real numbers, or are they categories, or are they an identifier? Are those actual real numbers, or are those categories or identifiers? So if they're actual real numbers, it'll be quantitative. If it's an identifier, it'll be unique for each and every observation, will not ever repeat. A unique categorical variable of group 1. A categorical variable will put things into categories, such as like company location. It's categorical. So what do you think this is right here? What do you think for 20 points on the line right here? What do you think this is? What do you think it is? Right answer might or might not be on the screen. Average chocolate rating is probably what? 20 points. Quantities. Yep, because we say how much is your average chocolate rating. Great job right there, Tiffany. It is a quantity. How much is your average chocolate rating? Quantitative variables must be numeric data. True or false? Like when we do a quantitative variable and we get a quantity of something, that has to be a number. Or it could be like dog. Dog can be quantitative. Bunny can be quantitative. Chocolate can be quantitative. Like if I ask you, how tall are you? And you say chocolate. I'm like, I like chocolate too. And you're like, then we just like high five over it. Quantitative variables must be numeric. Must they be real numbers? Must they? Must quantitative variables must be, that is yes, so very true right there. Yeah, they have to be real numbers because we can do mathematics on them. So they must be real numbers. A blank is a collected to make inferences about a population. MuBot is always there for us. MuBot, how about you do this question here, MuBot?
So I want to go out and understand UT students. What would I take? If I went out and talked to UT students, I would take a what to speak to UT students. I would try to understand them by taking a what to make inferences about all UT students, which is the population. We'll do more examples here as we go through. We'll do another version. But I would go through to make inferences, which means understand them. Would I collect a parameter, a sample, a statistic, or a variable? What would I collect to understand UT students? This is what is collected, not what we get from the collection of groups. I would go through here and take a sample. A sample is just going in and taking a small group from a population. So samples and populations are connected, but statistic and parameter are connected. Remember, SSPP. Sample, statistics, population, parameters. A sample statistic is like talking to 100 UT students. The sample is 100, and then the statistic is, what is their GPA? A parameter would be, from your sample of 100 students, you are estimating the true GPA of all UT students. Watch as we highlight these again, and we'll do more examples. I went out and talked to a sample of 100 UT students. I found an average GPA from that sample that was 3.7. That's the statistic. I am then going to estimate the GPA for all UT students, and my best guess of this truth, which is the parameter, is 3.7. MuBot, away!
We'll do some more examples right here, but this is a sample. We take a sample to understand a population. Just kind of think of how these words work. Variable is just a question we ask. So the variable would be, we'd get a statistic on a variable. The median is highly influenced by outliers. We will be covering this next time. I'm going to make sure I might extend this because I might put it to Tuesday. Because we will cover every one of these questions very in-depth in class. So let me do that right here. After we do the examples, I'm going to put this to Tuesday because that way we will have covered everything very exactly for all of this. I just don't like to go too quickly. I could have rushed things at the end of class day, but we'll get to stem and leaves on class 2. Could we do, you bet, 3E? We'll do that next, Kiana. You got it. Yep, because nothing's lined up. You got it. We'll do another example of this, and Tiffany will probably do the other questions. So I want you to think about a very, very small data set here. I want you to tell me the median of this data set. Are you ready? What is the middle number of this data set? 1, 2, and 1 million. What is the middle number of this data set? We can do that next year, Tiffany. You got it. What is the middle number of this data set? What is the middle number of that data set? What is the middle number of this data set up there? Think about 1, 2, and 1 million. What is the middle number on that data set? The middle number is what? What is the middle number on that data set? It is 2. Now, what if I change this and I change it to the following? What is the middle number on this data set? It's still 2. So what do you think, Jenna? Great job right there. 20 points, everyone in the chat. So do you think the median is influenced by outliers? So remember, you said the median was this in the previous example. True or false, the median is highly influenced by outliers. What do you think? Let's make it 3 million. And what's the median? True or false, the median is highly influenced by outliers. It's the middle number. Would that be influenced by an extreme value on one side? The middle number. No, Jenna right there. Great answer, Jenna. That is definitely false. Great job. Another 20 points, Jenna. Keep those answers coming. I hit 10 points. We'll throw another 20 points on that. So you are exactly right. What type of crime is least frequent? It's a pie chart, univariate display of categorical data. And then we're going to find Tiffany's other question right here. So this is violent crime is least frequent. You could also display this in a bar chart. Univariate displays of categorical data. That's got it. We should have another 10 out of 10. 10 out of 10. Let's go to another version of this. And we're going to find Tiffany's question right there about there's a Pareto. There's a bar chart. We're going to find the version that Tiffany had with the question about, we got some IQRs right there. And so let's find it. There's a lot of versions of this. Really good practice. Are we going to get... we found it. Okay, you ready? So how do we find the mean for data? How do we find the mean? How would we find the mean? Can anyone explain to me, if you have data, how would you find the mean of the data? This one asks the median. We'll do the median, and then we'll do the mean. Well, I asked the mean first. How would you find the mean of this data? I did, which is not the question. Be very careful. How would you find the mean for this data? If you had to find the mean for this data right here, how would you find the mean? Which is not this question. Mine says median. If you were to find the mean for this data, mine says median. You are correct. I did notice that afterwards. So if you were to find the mean for the data, find the average. Exactly. Add them all up. So if yours does say the mean, you want to add them up. And once I add them up, I divide by how many observations there are, which is 5. So the answer is 25 for this. But let's do this question right here, which says the median. So the median is the what number? The median is the what number in this data? The median is the what number in this data? The median is the what number? So always when you think of median, Tiffany, great answer right there. So the median is the what number? If we do median now, which this is now the median is the what number? It's the what number? The median will be the middle number, exactly. So what is the median on this? Pretty easy to see right here. It's just this number, which is the middle one. But how about I change this? What if I were to do the following? If I added into this 10, what is the middle number now? 50 points on the line. This is a tougher question. What is the median now? This is a tougher question. This is a very fair test question, but see if you can find the median now. 50 points on the line. Put a little chill music on right here. Find the median of this data set. Find the median. And I'm trying to trick you. I try to ask questions sometimes a little bit easy, and then we go to a harder type question. It's like a level 4 or 5 difficulty. Got a little trick in it. A little trick to make an error. Great job, Tiffany. Well worth the 50 points. Tiffany, you did not get tricked, nor did Jenna. Well worth the 50 points. Because when you do the median, you need to put them in order. So if you notice right here, we don't have a middle number anymore. So great job on that. We don't have a middle number. And that makes it average of these two. So you would average the two numbers right there to 22.5. So great job right there. Little tricky. Great job, Kiana. A little tricky right there. You have to put them in order. If there's no middle number, the two numbers are averaged together, but the numbers have to be in order. So don't just go straight for the middle number. Someone might have been watching this and been like, oh, it's the middle number, but they have to be in order. So since these are in order right here, like we're kind of very nice on this, it is 25. We won't always put them in order, but If they are in order, it's the middle number. If there is no middle number, as we see in this example, you average together the two middle numbers. So that's got it right there. There we go. Let's head back to the unzoom. And let's see right here. We got chocolate rating. We did this one earlier. It is quantitative. Average chocolate rating is quantitative. And a blank is a group of people or items we want to understand. Let's bring back new bot.
So what do I want to understand? Do I want to understand the statistic, the parameter, the sample, or the population? What is the group of people or items? Who knows what the group of people or items are? Is that the population, statistic, parameter, or sample? And this is what I want to understand. Like the group, not like a thing I am measuring. So listen to this again, we did it earlier. I go out and take a sample of 100 UT students. From that, I will estimate that the average GPA is 3.7, and this will help me understand, great job Tiffany right there, the population, which is the group of people or things I want to understand, and I can estimate the true GPA, which is estimated from the statistic. The population is basically all people, where the sample is just a smaller. Hey, what's up, Roderick? Shout outs to Josie and Emily, and oh no, I forgot one. Josie and Emily, shout outs right there. And so this is a population. You got away. Evil me that.
So with this right here, we've got some stuff. Just having some fun today right there. An identifier variable is a special case of a categorical variable. Ignore the typo. Is an identifier a special case categorical variable? True or false? Practice right here. Easy test points if you know it. You look at that and you say, even with that typo, you can't trick me. An identifier is a special case of a categorical variable. True or false? Is an identifier a special case categorical variable that is unique for each and every observation? Is an identifier, is what I'm saying true? I'll try to agree. Nice job, Tiffany. Congrats, Tiffany, right there. Let's throw some, let's go crazy. Once again, hashtag show up to office hours. Tons of points. 100 points right there, Tiffany, for that 100. It is very, very true right here. Compute the median. Okay, so we've got skew right here. Right to the high, left to the low, whatever way the what goes. Right to the high, left to the low, whatever way the what goes. Right to the high, left to the low, whatever way the what goes. Look at your little monster man right here. Right to the high, left to the low, whatever way. So you see his tail? This is a monster man. Right to the high, left to the low. And what do we mean by low right here? Low is the lower numbers, which is the left side, also known as negative skew down here. Right to the high, these are the high numbers. That's right skew over here. I'm blocking it. So right, this is the high side, also known as positive skew. It's good notes right there. After you help Kiana, can you go over chapter 2 more? You bet. You bet. Oh, great questions right there. Thank you so much. So is this left skewed? That's very true. Another 10 out of 10. There we go. Another, did I get 10 out of 10? I think I did, right? 10 out of 10. We did it. Awesome. So Kiana's question is, great job, Tiffany. You bet. And thank you so much. The people who show up to office hours like this and just keep working through the assignments, getting these hundreds, I'm not kidding you. I see a bunch of A's. And also, if you're watching the video right now, great job. People who use the office hours are oftentimes doing really, really well. Jenna, great job being here. Roger, great job being here. Just ask those questions. Let's go do Kiana's question here. I mean, it's like, hey, I can get this done with the help of the teacher right here. Can you go back? Yeah, let's do the skew. Sorry, let me. So when it comes to skew, Jenna, we'll come back. When it comes to skew, you want to draw your little monster man right here. So do you see how we got a little monster man? Here, let's go look at another distribution. Is this distribution you see on the screen right now right or left skewed? Is this distribution over here? I'll go to just it. Is this distribution right or left skew? Is it right to the high, which means the tail of the monster is pulled out to the high side, or is it pulled to the left side? What way does this monster's tail go? And it's just a neat little way or interesting way I'd teach it. I hope I'm interesting. This is like a humpback monster right here. He's got like this right here. He's got a spiny back. I would say that's the way the monster goes. It's right skew because this is the high side. So right skew, you're going to see that the mean, that's the mean right there in that diamond. It's like diamonds in the sky right there. That's the mean right there. And the median, we'll talk about this in class, is actually that bar in the middle. So I am pointing underneath. I can actually point to it if I lower it a little bit more. Boop. Now it's on my green screen portion. This is the median, and the mean is inflated right here. The mean is being increased by the right skew of this distribution, little monster man's tail over here. So when things are right skew, the mean is going to be higher than the median. That's a great note to take. The mean will follow the direction of the skew because it's going to go in that direction. It's going to get skewed higher. So the median is right here, the center of the box plot. We will be covering this in class. And the mean is right here. So that's the median, and that's the mean. And we'll cover everything in detail about this. Does that make sense, Jenna? I'll disappear so you can kind of see this. This is a right skew distribution where the mean is higher. I'll highlight it. Where the mean right here is higher than the median right here. And the mean follows the skew generally, which makes the mean not a good thing to use when you have skewed data. You'd rather use the median and the IQR. It's another topic right there. How are we doing, Jenna? Good stuff right here. Thank you, Jenna, for asking that. We're throwing Jenna some big 50 points right there. Thank you, Jenna. Anytime you have a question, let me know. Generally follow the tail. If you're ever really concerned, like let's say you're a big time stats person, you're like, hey, Brian, I don't like that whole, just look at the tail mostly. You can actually go to the summary statistics. Remember how I said right skew is positive skew? If you're really concerned, you can go to summary statistics, if you don't believe me, and go to skew, and a lot of programs have this. We have it in R. It's under the E1071 package. And you can see right here, it has positive skew. So this has positive skew right here. Now, this is a little more complex. I'll just do it for a few seconds right here. Let me load up the library, E1071. Can anyone tell me, is this data here right or left skew? Let's just go and make data. Is this data right or left skew? Is that data there right or left skew? Right to the high, left to the low, whatever way the tail goes. Is that data right or left skew? Is that right or left skew? Is that right or left skew? If we asked a statistician, we'd say, is that right skew data or left skew data? What do you think? Is that data right or left skew? That data on the screen currently is it right to the high or left to the low? Is right skew because the tail goes to the right. Great job, Jenna, right there. Another 20 points in the chat. So is right skew. This is my graphic. That is right skew, which means positive skew. You don't need to know positive skew. It's just the thing people use a lot of times. But now check out this data. This data looks more what, though? It's not really skewed. If data is not skewed, it maybe is more this. Think about this. You could fold this over. Like if I were to take this graphic right here and draw a line down the center of it, I could probably just fold this graphic over on itself. Like take this right here and then just fold it over on itself like this, and you would get basically the same thing on either side. This does not look so much skewed. It looks more what? What would be a good term to call this unimodal distribution that's also looking very what? It's looking unimodal and what other thing? Unimodal and also what other value? Unimodal and what? Think about the last word. Because you can fold it over on itself. Like you can just take it right here and fold it and it'll look the same on both sides. Unimodal and also, I might say it, symmetric. So now it's not skewed, which when I run the skew function on this, which you don't have to run, you'll see that the skew function comes back with a value very close to 0. We might see a tiny bit due to randomness, but a lot of the values of skew here are going to be very, very close to 0 because these are more of a symmetric distribution. The more skewed the distribution is, the higher the value. So on the previous one where it was very skewed, we see a high number, and I could also make it negative if I multiply this by times negative 1 times this. So now this should be a left skew distribution, which is going to be a negative number because the tail goes to the left. Does that make more sense here, Jenna, on how to interpret skew, whether it's left skew, right skew, or symmetric? So symmetric, not really any skew right there. Right skew, right to the high. Left skew, left to the low. So there's left skew, right skew, and mostly symmetric. And left skew is negative because it's to the left, And right skew is positive because it's to the high, right to the high, left to the low, whatever way the tail goes. And this one doesn't have a good tail indication. Jenna, thank you so much. Great questions right there. That's a very good topic. Pretty, like, once you get down, you're like, got it. But it's like a 50-50 shot on the test. So you could guess and get it right, or you could like overthink it and get it wrong. But we just try to practice and make sure we got them down. Kiana was wondering about... Kiana, can you repeat the question? Let me see if I can find it. Let me find Kiana's question right here. My chill music. Kiana was wondering about... Here we go. If there are any requests, could we also look at 3E on 474 Lab 1? One of these days, I think I should have like a TA to have these things, because there's a lot of things I could do if I had someone running the stream with me. But I don't know. People have been like, how do you do it all on your own? I'm like, I don't know. I'm a gamer. So let's look at 3E right here. Thank you so much right there. Kiana's repeating 3E. For some reason, my mic sounds a little bit on or off. I'm going to go back and listen to the stream, make sure it sounds correct. 3E. You know what I think it actually is? It's the headphones. Because now it sounds better. 3E. Focus, Brian, focus. 3E. Okay. Here we go. 3E for 474. Let's do this. Awesome. There we go. I think we got everything working now. Just doing some volume adjustments. 3E says, when we go down here, one of the simplest ways of handling missing numeric data is to replace the missing values with the median of the values that are present. Do this for your BAS vector. There are a few ways to do this, but the intention is for you to accomplish this with a single line of code using the brackets. So, which is .NA and median with appropriate additional arguments, so that you are not hard-coding any numbers this way. Oh yeah, wait. One of the simplest ways of handling missing numeric values to replace the missing values with the median. Okay. Do this for your BAS vector. The simplest way to do this is to accomplish this with single line code using the brackets. Okay. So now we want to find the NAs. So if you hard-code the values, so what someone could do, this is the bad way of doing it. This kind of walks you through the steps right here. What we're talking about with this BAS vector, this is the bad way of doing it. If you were to go here and look at the BAS vector and say, okay, position 3 and position 8 are NA. So let's go here and go to position 3 and position 8. And there's position 3 and position 8. And let's just go here to the median of BAS. NA remove equals true. So now I've hard-coded those values. Does that make sense what hard-coding values means? Because now it is going to position 3 and position 8, but it's because I told it. So that's what hard-coding those values means. It's not doing like a search operation to find the NA values, but that goes to the BAS vector, replaces position 3 and position 8 with the median, and we can see we've done that replacement right here, and we've replaced those values. So now we hard-coded the values of 3 and 8, but not the best of ways of doing things. So how can we improve this? We're looking to improve this portion right here. Instead of using those values, we don't want to hard code them. Let's reload the data, and I just hit the up. So it's not like exactly. So how can we find where the NAs are at in the BAS vector? How can we find where the NAs are at in the BAS vector? How can we find where they're at? Like, how can we find out, is something NA? How can we find out, is something missing? How do we find out, is something missing? How do we find out, is something missing? So I'm like, is something missing? How do I find out, is it missing? How would I find out, is it missing? It's kind of the answer. So how would I find out, is something missing? Does it have missingness? Is .NA and BAS. Yep. And so now you can see here where the NAs are at. And you know what? I literally think we can just drop a logical inside of here, and this will return the positions. That's got it. What beep is it again? I need to remember this beep. Do I have the prices right up? I have a shot. Ready? Library beep R. Oh, wait. I can cheat. Here we go. Yes. We've done it. And I've got my Final Fantasy fanfare right now. I don't think we get copyright claimed on any of these. You can make R play music, one of my favorite things. So with this right here, we've done it. We took the logical. You could also put this inside of a which will return just the positions. Gonna call from Tennessee. So which is gonna return just the positions right here. And we'll just take a look at what this looks like before we... So we're rerunning this. You don't have to. But this will return 3 and 8. So now it has 3 and 8. So here's the thing, though. After I run this, Kiana... So I've already ran and replaced the NAs. What will this return? So Kiana, really hard question right here. Kind of, I'm going to let you get 2 shots at this. 50 points if you get it wrong, but 100 points if you get it right. What are we going to get if we run this code right now that I've replaced the NAs? So if I tell it to give me the positions of the NAs in the BAS vector, and here's the current BAS vector, what does this return now if I run this code? So that's the current vector, because I ran the code and I replaced it. What will this code now return if I say, are there NAs, and then find the positions of the NAs? Tough question. First year coding Brian probably couldn't get this right. 50 points if you get it wrong, 100 points if you get it right. You got 2 tries. So I've already replaced the NAs. There are no NAs anymore. So hint, this will return back false, 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 false. And so what will this then return when I ask for the positions of the trues? So it's going to return the positions of the trues, but look at the vector, because there are no more NAs because nothing's an A. Ah, well, there you go. You got the points by running it. That's a great way to get the points. So what that means is that's an integer vector of length 0. Oh my gosh. That's an integer vector of length 0. So when it returns integer 0, it's a vector that is integer vector of length 0, which basically means like this. If you do this right here, we should get integer 0. And so this is what it's returning. So basically, Kiana, what is it returning? Kind of put the integer 0 in context. What is it returning? Like, I have made an integer vector, and here's what it's returning. So this is what you get, and here's a visual of what you get. You get this as an integer. So it's basically giving you what? That's visualizing what you're getting right there to say an integer vector of length 0. Because that is now a vector of length 0 that is an integer vector. And that's what this right here means, integer vector of length 0. So what is this vector? So the answer to what is currently NA, the answer is, or the positions of the things that are NA, the answer are there's, R is telling you what with this? Good thing to just put it into like normal person words. R is telling you with integer 0, there are what positions of things that are NA. So outside of coding, you would just say, well, there's now what? Since we've recoded stuff, if you ask me for the things that are NA, well, the answer is there's none. There's no positions that are NA. I have nothing to return to anymore. It's nothing, and it's an integer nothing. It's an integer nothing, so there's nothing. That's what that integer 0 means. There's null, there's nothing, a null object, and it's of length 0. So yeah, good stuff right there, Kiana. Great job. I think, was there another question after this? I think someone said after Kiana's, can we do another one? So Kiana, great work right there. And then Tiffany wants to know homework 2. Let's do it. Great job, Kiana. Keep asking those questions. We can come back, do more. 474 and 201. Amazing work. Let's go do some 201. So homework 2 for 201. Homework 2 for 201. And we'll go check this out. I think these things sit weird in my ear. Or I'm going deaf. That would not be good. And let's go here. Let's go to 201. There we go. There we go. That's originally, but it makes more sense. Yeah, Kiana, that's the whole point, is you try it on your own and then you get it working, or maybe it doesn't work, and then you come and you ask some questions. You're like, You see it. I can't tell you how many times Dr. Petrie has explained something to me and it's made way more sense. So it really is practice. I say that endlessly. I'm like, you got to practice. And everyone's probably like, but like, just like, yeah, Brian, we know. You tell us to practice every day. It's an instrument. Coding is a language. Music is a language. You have to practice. You want to get this good at piano, you got to practice piano. It's not going to come from watching me play piano. You'd be like, oh, Brian, you play piano so well. Well, you're not learning how to play piano then. You are learning how to play piano, learning how to code by practicing, by getting things wrong, by making mistakes. No one plays a song perfectly the first time. There's so many mistakes. They've changed how my Pearson works, so I'm trying to load up the assignment. Oh, I think I've done it. My Pearson, are you blocking pop-ups on me? Is my internet being slow today? What is going on here? We're getting the homework assignment loaded up as we speak, but my Pearson's being... It's literally not loading right now. It could be part of the issue. Finally, my Pearson's loading. Let's go to homework. Yes! It is time for Chapter 2. My Pearson. Let's do this. Yeah, I know, right? It is working for me now. I like the full screen on my Pearson, but you can always do it through Canvas. For display issues, I like the my Pearson better. Let's do this. So we have some terminology we haven't heard yet. We will be covering this in class, and these assignments are coming up. Not due yet. But we have here a what? A stem and leaf. So what was the most amount of home runs that Mark McGwire hit in a season? The most amount of home runs that Mark McGwire hit in a season was how many home runs? The most amount of home runs that Mark McGwire hit in a season was how many home runs? So look at this. I want you to tell me, looking at the key right there, what was the most amount of home runs he hit in a season? So take a moment and be like, okay, a stem and leaf. We're asking how many home runs did you hit in this season? And your numbers might feel a little bit different. Yep. So we're asking how many home runs did he hit in this season? So what was the most amount of runs he hit on my graphic? What was the most amount of home runs he hit in a season? We say, how many home runs did you hit this season? That's quantitative. So this is a stem and leaf, which is a univariate display of quantitative data. So what was the most amount of home runs he hit? Ah, good. I like that right there, Tiffany. Let's throw some points. Please don't change screens. Yes, didn't change screens. This here means 78 home runs in a season. This 2 is a season, so this is an observation. He hit 52 home runs. What does this 2 represent, Tiffany? Like, connect the numbers and look how the key works. 7-8 represents 78. So what does this 2 represent right here? What does this do? This is just a number line. These are not actual observations. These are the observations. And I'm going to draw a stem and leaf here in a moment. What does this 2 represent right here? So connect the numbers and be like, oh, according to the key, 7-8 is 78. So according to the key, 4-2 would be what? 4-2 would be what? How many home runs did he hit in a season there? 4-2 would be what? Best level in Mario. 4-2 would represent 42. How about this? If I ask students what their GPA is, great job, Tiffany, right there, another 20 points. If I ask people what their GPA is, so if I say, what's your GPA? So just think about this. I'm going to put my GPA in the chat. My GPA, my high school GPA was like a 2.6. I need to call and get that, but it's about 2.6. If someone else puts their GPA, they might say 3.2. Someone else might have a 3.8. Someone else might have a 3.3, and so on. We could just go through here and keep listing GPAs. But what about right here? If I draw out people's GPAs and I go 4, 3, 2, and I put a key down here and say 3-8 equals 3.8. First question, where would Brian be? Can you see where Brian's going to put his number? So Brian is this. So how would we represent Brian over there? These are not observations. This is just a number line. It's just the people who have 2 point something, 3 point something, 4 point something. Those are not observations. Observations will go over here in this region. This is where the observations go. Hey, what's up, Cliff? Good to see you here. Ask any question. We got open floor after this, I believe. So ask questions. So Brian will go over here on the stem and leaf right here. That is an observation. Brian had a 2.6 GPA. Great job, Tiffany, right there. Yes, you're getting it. And then over here, we'd have a 2 and we have an 8. And these represent these people respectively. Like here's the 2. So there's the person with the 2. I can't draw stars. There's this person. These are individuals right here. Does that make sense? Oh, wait. Oh, no, that's correct. Oh, we forgot one person. We got another person. I'm sorry, I forgot you. I forgot this person. There we go. We've done it. Does that make sense that each of those numbers right there represent individuals? Like we talked to 4 people and Brian had a GPA, sorry, Brian, of 2.6. Another person had a GPA of 3.2. Another person had a GPA of 3.3 and 3.8. And then the observations are over there on the stem and leaf. If we drew a histogram, it'd look basically the same. A histogram is going to look virtually identical to this because we'll have the 2 to 3.0 and the 3 to 4.0, and this will be that much higher. So the histogram for it would look something like this right here, which you notice looks like that graphic up top, where you can see right here, this is 1 individual, and this is 3 individuals. So there are 3 people in this group. Like this group right here is represented by this, and this right here is represented by this group. Well, maybe I shouldn't use that color because here's the number line down here, and here's the observations. So does it make sense, more sense now, Tiffany, how a histogram and a stem and leaf are connected? These both have a bin width of 1 because they have the same length on the number lines. But you can see right here, we've talked to 4 people. We can display it as a histogram, or we can display it as a stem and leaf. And then the stem and leaf will have a key to indicate what the numbers are. So always look at that key on a stem and leaf to better understand. Just think of a stem and leaf as a histogram, because you could draw the histogram on top of it. We could just do this right here, and we've drawn the histogram right here, which you can see there are 3 individuals, and there's 1 individual here. How are we doing, Tiffany? Making a lot more sense how a stem and leaf is just a histogram where you can see the numbers. Like here's our 2.6 person, our 3.3, our 3.2, I mixed them up, and our 3.8 individual. They make up the height of that bar. So they're inside of here. The height of that bar is that there are 3 individuals, and the height of the other bar is that there's 1 individual over here. So histograms and stem and leaves display the same kind of data. If you're wondering what a dot plot is, which will cover everything, a dot plot's the same thing, except we just use dots. So there's a dot plot on top of it. Same thing. Just use dots instead of bars. So if you were to technically erase the bars right here, now that's officially a dot plot. So we've seen a dot plot, we've seen a histogram, and we've seen a stem and leaf, which is where we kind of ended off today. Good stuff. Let's go back and look at that question. And the question asks us, none for a category? Then he never hit in the 60s. So he never hit in the 60s right here. Does that make sense? At no point did he hit in the 60s for his home runs. So he just never had a home run season where he had 60s. It's just, there's no data. Remember, this is where the data is. So he had 78 home runs one season, 52 one season, 57 one season, 42 a season, 44 in a season, 44. So like maybe in like 1992, he hit 20 home runs. Ooh, that's weak right there. Got to hit more than 20 home runs. When we see right here, it says, is it unimodal, uniform, or bimodal? So unimodal means 1 mode. Bimodal means 2 modes. So unimodal, bimodal, and uniform. So think unimodal, 1 mode. Unimodal, bimodal, uniform. So with this right here, which of these does it look like? Does it look like it has a 1 mode, which means modal area, peaks, 2 modes, bimodal, 2 peaks, or uniform, 1 form across the top? What does it look like to you? Unimode, like 1 mode here, uniform, or bimodal? Be careful, we want to see clear peaks. Which of these does it look like? Like it has one peak, one clear peak, two clear peaks, or is it flat across the top? What does it look like? Remember, unimodal. So it's going to be unimodal. When we see bimodal data, we generally want to see two clear peaks. It can be tough sometimes, like, is it unimodal or bimodal if you have smaller peaks, which you do sometimes have. You could have data that looks something like this, and that's mostly unimodal, a very small second peak. At this point over here, I might start saying it's bimodal. And so there's a gap. Oh, good point right there, Tiffany. There's a gap. Let's throw in Stuart. Great job, Stuart. Let's throw 50 points for Stuart and everybody jumping in. Love it. There's a gap in the data. So we'd call this a gap right here. We generally want to see, whenever we have bimodal data, two clear peaks. If you see a very small like this, that just might be what's 50 points in the chat. If you can tell me, maybe that's not really a second peak. That's more of a what here. I'll use my example I use. That's not really a second peak. Mubot says you're welcome. That's not really a second peak. That's really just outliers. Great job, Stuart, right there. Imagine if you tell your friends, I ran up a hill. So if you run up this hill, that might be a little bit impressive. It'll make the little guys smaller. So if you were to tell your friends, I ran up a hill, this would be impressive, right? But if you tell your friends, I ran up the hill, would your friends be impressed by you if you ran up this hill right here? If you say, I ran up this hill, is that really a hill? Or is that just like a little, I don't know. Say, I ran up that hill, and they'd say, it's not really a hill. So think of it as the more clear the peaks are, the more bimodality there is, because it is a matter of degree. It's like, at what point is something bimodal? It just depends on how separate and how clear the peaks are. It could be trimodal, quadmodal, quintmodal, sexmodal, octmodal, multimodal, we generally just call those. But they wouldn't be impressed. I agree, Tiffany. They'd be like, what? You ran up that hill? This is the real hill. There's one hill, and then there's just a little bit of a mound of dirt over here that like fell off this hill. Whee! So this is the real hill, just like this is one hill right here. So at this point, this would also be still, I would say that this is still unimodal, but with outliers. I'd say that's unimodal with outliers. So good stuff right here. Ouch. Maybe a little bit of right skew, maybe a little bit of outliers, but that's really just kind of unimodal with outliers right there. And good stuff. So this is unimodal. Final check. Got it. And is it symmetric, left skew, or right skew? Whew. This is a tricky one. Now, what is our saying? Left to the low, right to the high, or right to the high, left to the low, whatever way the tail goes. Right to the high, left to the low, whatever way the tail goes. Now, don't be tricked. This is going like reverse order. Hopefully it doesn't trick me. I want you to notice what I'm doing right here. I'm putting it so that the number line is how we'd normally look at number lines. It is making it weird to look at. But notice how the low numbers are on the left side right now. This is where people get tricked. Here's low numbers, and the low numbers are on the left side, which is the negative side. It goes towards negative numbers. Here's the right side, or the high side. And this is the right side. And this is the positive. So it is left skewed. Little Monster Man, I'm pretty sure this one has tricked me before. Little Monster Man's looking like that right now. This is a tricky one. I'm pretty certain it's left skew. We're going to find out the hard way right here. We showed some more classic examples earlier on with things that are symmetric right here and things that are right skew, because look at your little Monster Man. He'd have the mouth here and then his tail going there, or left skew. These are like your classic examples of left to the low. Look how the tail goes to the left. This is the tail down here. Right to the high. Tail goes to the right, high side, or mostly symmetric. This one is iffy. Little bit of a left tail. We're going to cross our fingers here. You always have to cross your fingers when you answer these questions. I've been teaching this for years, and I'm still like, oh, they call this left skew, right? Woo! We got it. Not today, my Pearson. Not today. Because someone could say it's mostly symmetric. If someone was talking to me, I would accept mostly symmetric with a high outlier. Like, it's mostly symmetric. Better answer. So now we have the center of the distribution. Is the center of the distribution in the 0 to 10, 20 to 30, 30s, 40s, 50s, 60s, 70s? If you look, it's probably about around 35-ish. So the only answer that corresponds to 35-ish, thank you so much, Roderick. I appreciate it. 20 points right there. The only answer that corresponds to around 35-ish is 40s. Sure. It's where the peak is. It's where the modal area is. I'll take that. I think it's more towards 35. I was kind of averaging those two together, and that's the only logical area that makes sense. The number of home runs per season's range, and so I'm going to pause here. I want you to answer this because this means you know how to read a stem and leaf. The number of home runs per season's range from a low of this to a high of this. So what is the lowest amount that we see here? Make sure to read it. Use the cheat sheet right here. What is the lowest home runs per season, and what is the highest home runs per season? Is it 8 and 8? Would the answer right here be it goes from 8 to 8? What is the smallest amount of home runs? What is the highest amount of home runs? So remember, these are the observations. This is a season, that's a season, that's a season, that's a season. These are all seasons. This is just a number line, 8 to 78. Great job, Stuart, right there. Another 20 points. Keep answering these questions. This is practice. The more you do it, you may be like, I can get these questions right, but then you got to remember it for the test. Great job right there. Also, for mine, 8 to 78, great job. One homework question down. Oh, another one. Do you see any unusual features? 78 is a bit of an outlier. Boom. 78 is an outlier, high point that is unusual. Stats got this homework question down. I'm going to put a break in the video so I can see where this is at. Let's do the next question. We'll finish off the whole homework. Please ask another question for 320, 474, 475 if you have it. I think we got another at least 28 minutes. But let's go to the next question right here. I put these breaks so I can find them. Let's go to the next question. Who can name in the chat for 100 points the three displays of univariate quantitative data? I'll show you the answers here in a second. We just talked about a few of them. Actually, we just talked about all of them. Oops, wrong slide. We just talked about all of them over here. If I go back in time, we might get to see one of them. So we were talking about displays of data with the previous question. And what are the three displays of data that we have for univariate quantitative data? There was an outlier, Tiffany. There was an outlier on the high side. There was a high outlier. What are the three displays of univariate quantitative data that we're talking about? There's more, but these are the ones we talk about. So I've got them all drawn out right here. I have all drawn out. I don't like this one, which is the theme of this question. What are the three displays of univariate quantitative data? And what do we mean by univariate? We're asking one question like, what is your GPA? So that's a univariate question. What is your GPA? You could make it bivariate by saying, what is your GPA and how many hours have you studied in a week? So how many hours do you study a week and what is your GPA? Could be bivariate questions, like two questions are asked. So we could display that in a totally different display, which I'll mention later on in class. But notice how we're just asking one question right now. What is your GPA? And it's a quantitative question. So we could use what, or then over on the other side of the screen, what. So what could we display univariate quantitative questions with? Univariate, like I say, what is your GPA? Or how much is your GPA technically, because it's quantitative. How much is your GPA? And we could display it. Tell me one of the graphics. I'll throw some 50 points in the chat. What's one of the graphics we could display? How high is your GPA, or what is your GPA? Because remember, it's a quantitative question. Even if we say what, it is still numbers. It's actual real numbers. So we have three different univariate quantitative displays. You want to make sure you have these down. Flashcard. 3 univariate quantitative displays of data. Flip it over, and what do you see? Well, this is the question. 3 univariate quantitative displays of data. Boom, you flip it, and you see, you should be like, oh, the 3 univariate quantitative displays of data are what? Ooh, I'll help you out right here. Yeah, we can do it next, Kiana. You got it. Oh, and then I put box plots. Well, there's 4. We'll do box plots later on. If you look up there on the top, way up there at the top, you will see, you got to look, I can't reach to it, but all the way over there, you will see histograms, stem and leaf, box plots, dot plots, and I think it's everything up there. Histogram, box plots, stem and leaf, and dot plots. So those are all the univariate quantitative displays of data. A box plot is going to look similar, or it's going to work with histograms a lot of times. We might see something like this for it. It's going to be a weird box plot for this one. But there's a box plot right there. So now actually we have all 4. Let's label real quick. We got here the stem and leaf in 1. We got here the dot plot in 2. We got the histogram in 3. And we got the box plot in 4. And those are your 4, your stem and leaf, your dot plot over here on the far side, your histogram right here, and your box plot here. We will be covering all these in class. So this is a dot plot. And all it does is just count the observations that we have for each group. If we notice right here, let's see how many sixes we have. We have 1 6, and that's going to help us narrow it down between this graphic and this graphic. How many 2s do we have? 1, 2 2s. So it looks like it's this one because we have the 2 here and the 2 here. So there's the 2 observations. And then we have the 6 here. There you go. There you go. Is this unimodal? I want U, B, or is it unimodal or uniform? Now, this one right here is uniform. This is uniform. This is a bit bimodal. It's got like 2 peaks. I don't love it, but it's more bimodal. Is this unimodal or bimodal? Is this unimodal or bimodal? So is that like mode 1, mode 2, mode 3? Think of it as a mountain. If you're climbing this mountain, how many peaks are there to the mountain? 1 or 2. So is this unimodal or bimodal? You just want to think about peaks to a mountain. And this has just 1 peak. So it's got just 1 peak right here. Is it right or left skewed? Ooh, I'm going to pause on this. L or R in the chat. Remember, right to the high, left to the low, whatever way the tail goes. Draw your monster man. I'm gonna wait for someone to answer this. Right to the high, left to the low, whatever way the tail goes. Someone always misses these questions on the test. Right to the high, left to the low, whatever way the tail goes. Is this right or left skew? Make sure to... Hey, Joseph, good to see you here, Joseph. Is this right or left skew? Right to the high, left to the low, whatever way the tail goes. I'm going to draw the monster man here in a second. That'll help give it away. Ah. Right to the high. Little monster man dude. It's got a right tail right there. It is a little tricky. Usually you'll see kind of the slope on one side to it. It's like steeper slope. I know this is the steeper slope here, but I think probably our quintessential examples, the easiest one to see is this is right skew. Yeah. Just tell me where you're stuck on, Tiffany. This is right skew. This is left skew. So does everyone see right here that this is left skew? And this is right, and the other one... Yeah, good. That's a lot of text. Right skew, left skew right here. This is right, and this is left. Does that make sense? And Tiffany, feel free to ask which one you're working on, and we can pause right there. But this is left. Does everyone see the monster man's face would be here? And then this would be right skew, because the monster man's face is going to be here, and the tail would go down. And then this is symmetric. These are like mostly symmetric right here. Which one are you on, Tiffany, right here? We're talking about the skew of it. Tell me if I've went too quickly. This is going to be right skew. I was waiting for it to say wrong, and I'd be like, no! And which of these best describes the center of the data? Now, you might feel like you have to calculate the median here, but when you do the median, like if I had a bunch of data right here, and let's say my data was... because I actually selected a wrong answer. Oh, you have to finish the whole question and go to similar question. So finish the whole question and then go to similar question, and that's how you can redo it. Once you complete the question, you can do similar question. So if we have a whole bunch of data, can anyone tell me the median for this data set right here? What is the middle number of this data set? And hint, there is no middle number, but what is the middle number of this data set? Which is kind of like our data set, which will kind of give you a hint. What is the middle number of this data set? Which there is no middle number. So what is the middle number? And I'll explain why we're going to use this here in a second. The middle number on this data is what? 3.5, because we're going to average these two together. Now, I want to draw one of the most important graphics we have right here. One of the most important graphics we can remember to do, and this is question if you normalize a distribution via log. Ooh, Connor's here. And you get the standard error. Can you untransform those standard errors to get a more realistic value of what the values might have been outside normality? Connor, you make me think. That makes sense. I mean, you can always untransform, right? Logically, that makes sense. So you're getting, I mean, basically you're getting a standard deviation. So wait, but why wouldn't you just... So wait, you're transforming a distribution, and then you're getting the standard error. Can you untransform those standard errors to get a more realistic value? Do you not have the original data anymore? I would just take the original data and get the... but you're transforming... Well, no, wait. Because you're... No. Oh, gosh, that's a tough question. That's a really tough question. If you have the original data, just use the original data, I would say. It's probably my best answer is just get the standard error from the original data, not the transform log standard error. But it would make... You know what, Connor? Let's test that out here. Connor, we're going to do that next. So let me find out the answer to that, because we can find out the answer, just simulate it and find out the answer. So we have here center. Great question, Connor. Connor asking Brian some tough questions right there, like super tough. And then we have right here normal. And then we have here skewed. So if the data is skewed, what is the best measure of center? This is a super important understanding we need for our test. For 201, and Connor's literally doing this right now for jobs, I bet. So if data is skewed, what is the measure of center? Because this relates to Connor's question about transforming data to achieve normality. If the data is skewed, what measure of center should we use? Because we want one that is not going to get impacted by skew. And we will cover this in class. If you know this, you're way ahead. So 474, 320, this is a good review. 201, this is what we'll be covering very soon. So if the data is skewed, the best measure of center is said to be what usually? Because it's not going to be impacted by outliers. If the data is skewed, the best measure of center is going to be what? Hey, Parker, good to see you here. If the data is skewed, the best measure of center is going to be what? What will not be impacted by outliers? Don't worry, just take a guess if you want. We're going to throw 50 points for any sort of guess right here. What is the best measure of center if the data is skewed? Skewed means it's just like pulled in one direction, like that's right skew right there. So what would be the best measure of the center, which is the middle of the data, if the data is skewed? If the data is skewed, the best measure of center is going to be the what? I'll give some ideas. We could use the mean or the median. The median, Kiana, great job right there, and everyone 50 points. So the median right there is going to be our best measure of center when it's skewed. Now, if it's not skewed, people generally just use the mean. And so Connor was actually asking about standard errors, which are basically based on samples and are kind of like standard deviations. So a standard deviation for 20 points is a measure of what? Just like the IQR, which we'll go in more detail on, is a measure of what? We'll be having whole lectures over these, but the standard deviation and IQR are both measures of what for data. So make sense of this graphic right here, because this is concentrated knowledge right now. The standard deviation and the IQR are both measures of what for data. They both tell you they're metrics to understand the what of data. Hint, I'm decreasing the standard deviation right now. Hint, I'm decreasing the IQR right now. Increasing now. Decreasing IQR, increasing IQR. These are measures of how much the data is what. If I change this, I'm changing the what of the data. I'm also technically changing this. But I guess it's hard to not move the graphic and change this also. Now I'm only changing the center where it's located center-wise. So here I'm changing the center of the data. And then the IQR and standard deviations are a measure of how much the data is what out. So the IQR and the standard deviation, if I make a smaller standard deviation, it starts to look like this, which is just a measure of how what for 20 points the data is. Measure of spread. Kiana, great job right there. It's just a measure of spread. And then why do we have two different ones? Either the data is considered to be normal, and we'll use mean and standard deviation together, or the data is said to be skewed, and we'll use median and IQR together. So what do we first need to know about data? The first thing we need to know about data is going to be the shape of the data. And this right here for 201 is a very important lecture coming up. Shape, center, spread. We will start this next class. Not today. Next class, we'll pretty much be getting into shape, center, spread, which deals with modality and all that good stuff right there. So that's got it. That's the ideas we need to know for this. So this data right here was said to be skewed. So should we use mean or median? What do you think we should use? Should we use the mean or the median because it's skewed? Remember, this data here is skewed. So should we use the mean or median? So the data is skewed. So should we use the mean or the median? Does that know? Oh, sure. A different number on what? You have a different number on what? If you're on Discord, hop on Discord anytime, and then it's really easy to message. We can meet on Zoom too. The data is skewed. So since the data is skewed, should we use the mean or the median? Since the data is skewed. The data is skewed. Or the data is skewed right here. So should we use the mean or the median? So make sure to have your cheat sheet here. And so the data is said to be skewed. We should use the what? The median. Kiana, great job right there. We should use the median. Yep. And these come into play in 474. These sorts of ideas. The spread of the data, they're just using the range right here. So they're going from the lowest number to the highest number, 2 to 6, which is also another way to talk about the spread. It's just the range of the data right there. So we got the range of the data. Describe any unusual features. This one does not have any gaps or outliers, so it has no unusual features. We'll finish off this quiz right here because this uses jump here in a second. So we'll finish off this quiz, then we'll do some 474. I think we have time. We have to... So we'll finish off this quiz. We'll finish it off. Here we go. Okay, let's do question number 3, and we'll do the 474 question. We got it. So let's do question number 3. I might speed it up a little bit, but let's go to question number 3 here on the homework. Let's do it. So here we are with some data, just straight data inside of this, and it wants us to find the median. Now, the easiest way to do this, you can do this by hand. So if you don't have jump right now, you can write down all these numbers and then find the middle number. But if we go here and copy to clipboard and hit Command-C or Control-C on our keyboard, we can go inside of jump, and inside of jump, we want to go to File, New, Data Table. File, New, Data Table. Under File, New Data Table, it is very important that when you go here, you go to Edit and Paste. Just Edit, Paste. We've done it. With Edit, Paste, we've pasted in the numbers. There was no column name right here. So now we want to go to Analyze, Distribution, and double-click the variable. Let me slow that down. Analyze, Distribution. This is going to allow us to view the distribution of number of runs scored, I think it was. So we're just going to go to Analyze, Distribution, double-click the variable, click, and then we're going to go over here and click OK. Now we're going to click the top arrow, right here, the top right arrow, and we're going to click Stack. And once we go here to stack, guess what? There's the median. Now, once again, this can be easily obtained if we go to sort and we just write all our numbers in order. We could obtain the median by just going here and finding the middle number, which is 47. 47 is the middle number on this distribution right here. There are 1, 2, 3, 4, 5 numbers above it and 1, 2, 3, 4, 5 numbers below it. So if you write down all the numbers and then just put them in order, 47 is the middle number, which is the median. So once again, you can do this by hand, or you can do it the easy way with jump, which I prefer. I vastly prefer just going to jump and being like, well, what's the median? So 47 is going to be the median. Make sure that is the middle number. 11 numbers, it is the 6th number. There are 5 below and 5 above it. What are the lower quartile and upper quartile? Now, I think we fixed this because there's been issues. So the lower quartile right here, we have never asked anyone to do these by hand, but you would have to create 2 separate data sets right here. You'd have to create a lower data set and an upper data set, and here would be your lower data set, and 38 is the middle number for the lower data set, and here's your upper data set, and 59 would be the median for that. Because notice right here, this is the middle one, and this would be your upper data set. 59 is the middle number here. We've never had people do this by hand on the test. We usually have you look at jump output. So that's a better thing to understand is here's 38, which is going to be the median right here. And here's 59, which is the median over here. The Q3 represents 75% of the data is at or below 59. The 38 right here represents 25% of the data is at or below 38. So that's what the 25th percentile means. 0th percentile means it's the minimum value. That's the minimum value right there. The 100th percentile means it's the maximum value. And you see the 5-number summary. So make sure you understand how this is connected right here. You will not need to find Q1 and Q3 by hand on tests. We usually give you jump output. We do sometimes ask for the median by hand though. So knowing to put the numbers in order is very important. But then the Q1 and Q3 are kind of the medians of the upper and lower set, but we don't do this by hand. So we have here 38 and 59 just from the jump output. There we go. That's got it. Last question. Then we're going to do a little 474. Okay, stretch out right here. Get that stretch. Get ready for that last question. Here we go. Last question on the homework. Let's get it solved. Here we go. So now we have a very similar question. I took some questions off previous semester. Terry, I hope you've done the same. We're going to find out the hard way. I hope this is not the one that has the problem. So with this right here, it wants the mean, the median, the quartiles, the range, and the IQR. So these are all different measurements for data. And here we see the values of the electronic smooth top ranges rated from very good or excellent. And it's just the prices of them. These are the price. How much does it cost? And so let's go here, copy to clipboard. Slow it down a little bit. And with copy to clipboard, we're just going to be able to copy the data. We're going to hit Control-C, Command or Control-C. And now we're going to go over here to jump. We're going to go to File, New, Data Table. Pause here for a moment. Make sure to pause the video if you need. File, New, Data Table. Now, it does not have a column name, so we're going to go to Edit, Paste, because it does not have a column name. And we get the data. There's the data. And now we're going to go to Analyze Distribution. If you're using a Mac, it'll be all the way at the top. You'll have to go to the top bar. And on Analyze Distribution, we're just going to double-click the variable. And now we can click OK. And it's going to give us a lot of the answers, which is awesome. We're going to go here to the red arrow and go to Stack. It just makes it look nice and pretty. And we go to Stack. And there we go. Let's check this out. So the first question asks, what is the mean? Now, to get the mean, you would have to add up all these numbers and divide by the total. This is going to be one of the ones that Jump's going to get mad at us on. I'm going to have to do this by hand a little bit. This is one of the ones we're going to have to do by hand at the end. I know it because I've done it. I thought I removed this question. So here we are. The mean right here is the sum of all them divided by the total. And so this is going to be 985 right here. And that's just all of these prices added up divided by 10. Now, the median we're good on. So let's take the data and let's just show how the median is found. To find the median, what you would do is you would take your data, and I'm clicking here and sorting it. So I'm sorting my data, and I'm just going to put it in order. Since I've already made something, it has to make a new sheet. So we're going to right here, all the data is put in order. And this is really nice. I'm so happy. There's no middle number right now, but what do you notice? Who in the chat can tell me what the median is? 50 points if you can tell me what the median is. There is no middle number. There's 5 numbers here and 5 numbers here. There is no middle number. So what is the median? I put them all in order. So what is the median right here? 950, Kiana, excellent work right there. Great job. Kiana, 100 points, following along, answering all these questions. This is the practice. Even if you're in upper level classes, it's good practice. Now here's where we're going outside of jump. There's multiple ways to calculate Q1 and Q3. So what you do here, average exactly. And so now think of this as a upper data set and a lower data set. So here's the lower data set. Is it going to ask Q1 next? What is Q1? So if you look at the lower data set right here, and here's how to solve this. What is the median of this data set? What is the median of the lower data set? I want you to only focus in on the bottom 50%. So this is Q1, which represents the bottom quarter, the 25th percentile. What is the median of this data set? And this is what my Pearson wants. They want you to solve it this way. This is one of the few questions that works this way. I've done it a lot, and we're going to make sure we get it right. Keanu's right. It's 850 because this is the middle number of the bottom data set. So we go right here and go to 850. We will not have you do these by hand on the test, but it's not the end of the world. It's not a horrible question. And then up here, let's grab the top part of the data set, which are the top 5 numbers. Look how I divide it in half. And then let's go ahead and... Oh, watch. Well, we can't do it. Well, do you see what the middle number is here? And I don't care. Another 50 points. Everyone following along. What is the middle number on the top portion of the data set? What is the middle number for the top portion of the data set? What is the middle number for the top portion? This question has to be done this way. It's the answers it wants. There's just different ways to calculate Q1 and Q3. I've actually looked into the documentation, and I wish Jump did it the way that they do it. It's going to be this right here. Sorry, I misclicked. It's the top 50%, the middle of the top 50%, which is the 75th percentile, is going to be right there at 1100. And that is how to ace that portion of the question, which is probably one of the hardest parts of this assignment. What's great is we can go and find the range of this by just going to the largest and smallest value. The range is going to be the distance from 800 to 1250. If you want, double check on your calculator by going 1250 minus 800, and you should get 450. Double check your answers, never hurts. The range is just the max minus the min, and now the IQR is the interquartile range. Here we are with the interquarters, so what is the range of these numbers? What is the range of those numbers right there? What is the range of these numbers right here? Like, how far apart are these numbers? Q1 to Q3, which is the interquartiles, how far are those numbers apart? Here's what it looks like visually. We have found Q1. We have found Q3. So how far apart are these numbers? Just mathematically. That's what the interquartile range is, the range from Q1 to Q3. 250, you are correct. And once again, you can do big number minus small number, big number minus small number, and there's the IQR. Just the range of the middle 50%. And visually, and we did this yesterday or so, it looks like this, where the range is all the data, the IQR is just the range of the middle 50%, the interquartile range. And I think that's got it. We've got 100. Let's hop into this. Let's put on a little rock music right here. We're going Hacker Man, Kiana. We're going to finish this off right here. We're going to answer Kiana's question. I'm going to go teach class. So Kiana, can you put your question in the chat again? You were wondering, and we've got Connor's question. We might have to come back for that. Question number 6 on the lab, getting your conditions to work. Let's go Hacker Man right here and finish this off. Okay, question number 6 on the lab. We might have time. We got time to do this one. Oh, yeah, we got the retailer data. Okay, here we go. Question number 6. The file retailer contains real data spanning over 4 years. From a company that sells products online and TV, the data is aggregated at weekly data. So most fields combine the details of product groups over a course of a week. For the sake of anonymity, product groups' names have a script of most of their data. I have made a modification to one of the variables to keep things interesting. Otherwise, the data is kept the same. Wait. Oh no, create a subset called sub of households spent between this and this amount. Okay. I went to the wrong one. What data set are we working with right here? What data set? No worries. Oh, Connor, I should message you on it. I bet we can do some tests. What data set are we working with right here? Create a subset of households. Create a subset of households. What data sets do we have in here? Gotta be data, right? Yeah, there it is. Create a subset of households. We're gonna store into sub. We're gonna use the subset function. We should be using dplyr. Connor knows about that. I've been doing some more dplyr and it's really awesome. More tidyverse. Connor, I need to show you what we're doing in 475. And I should have you talk to some of my students because some of the stuff they did was absolutely amazing this summer. So we want to subset. The first question is, what do we want to subset? If we want to come back home earlier, yeah. You can just come back. You can just check out the video at any time. The video will be posted right after it's done. So you can always just check it out anytime. So we want that they spent between that and that amount. So this is a condition right here. So I'm going to write one condition. I'm going to go to spent. And we're going to go that they spent more than or equal to. So that's the variable spent, but I didn't do the capital. Spent more than or equal to 1,500. And now we've subsetted. And now we want also that they also, we go here and go and, that they spent less than or equal to, and 4,500. And I'm going to watch this subset right here every time to make sure it decreases, to make sure I'm subsetting further. I also still have certain variables who are homeowners. So we need homeowner equals yes, do we? So now they need to be and a homeowner equals yes. Oh, see, we misspelled something. Homeowner equals, is it homeowner? Double check. It's homeowner. There we go. Now we actually have a subset. Do I need to click save or... Oh, you can exit out. Yep. It'll save everything. And whose incomes are either this or this. So this is a tough one right here. Oh my gosh. This one right here, we want this or this. So we want... This is the best way to do this. We want that their income... Whoops. I forgot something. And their income... There it is. Income is contained in the vector. This and the or is a comma. And so I think that's got it. These are all the conditions right here that we have. And we have here, it has 16, but now we have to add in another argument. Sorry, I got class in 18 minutes. Select, we're going to select certain columns out of this. And let's go to the columns it wants us to select right here. And now we need a vector of the columns we're selecting. And I hate when you copy paste, sometimes it does this. It didn't put the right quotes in here. So I'm having to rewrite the quotes. And so it put wrong things. And is not a comma. So we are just rewriting these with quotes right there, and we've done it. Did that help at all, Kiana? Or no, that is like, no. But going through here, seeing how I talk through it and maybe explain, I hope, since we've got 17 minutes till class. Did that help at all, Kiana, to see it? We've now created the subset, going through writing the conditions with the ends and the contained ins. And then this was a new argument. All of this right here is one argument. I think that's what confuses people. That's all one argument. Notice how there's no comma to start the new argument till this. And I'm using the sub indent right here, which it does for me, to indicate that everything right here is one argument. You're welcome, Tiffany. Great work, Tiffany. Great work. So I'll see if this helped Kiana. I'm hoping you can see there's 3 arguments right here. What are we subsetting? What are the conditions? And then what columns are being selected? So a little bit tricky right there using the subset, going through all the conditions. And notice how this is a string. These are strings it's searching for in the data. So you can see how the variables look. I think that's got it. Hold it off. You're not getting 16 observations. Maybe message me on Discord or email me and we'll get it looked at and we'll see why you're not getting 16 observations. If you're getting 0, there's probably a typo. Try deleting certain parts of the code. Like be like, okay, let's remove this condition and you should see it go back up. So try like removing conditions right here to see if you go back up, and you can kind of see my sample sizes go back up as I do less and less conditions for saying subset further down. You're welcome. Great job, everybody. That's got it for now. We'll be back next time, everybody. As we like to say, what do we say, Puppet Shark? No, we say bye for now. Bye.